Today we will see GPIO configuration. What full form of GPIO? General purpose input output. It will be easy for us to go with the block diagram of GPIO. So I am drawing block diagram, basic block diagram you can say of GPIO. GPIO has two buffer. Here I am drawing in two buffers, one input and one output. Okay, so I am connecting line here and line here. Okay, then both are connected to pin. Okay, and this is an external side. Okay, this is a pin. I'm writing here pin. Okay, this is an input buffer and this is an output buffer. I will also explain what buffer, what are the things inside these buffers. Okay, first of all, see, only we are seeing the basic block diagram of GPIO. Okay, I also have an here enable line. This is an inverted. Okay, inverted enable line. One connected to output buffer. Here it is not inverter. You can say inverter here. Okay, and same enable line it's connected to input. This line is connected to the port. Okay, we have to consider some points for this. By default the GPIO configured as input, as in input mode. Okay, if we want as an output, then we have to configure them as an output, but by default they are input mode only. So how we will configure as an output? Okay, we will see how that configuration is done. Okay, first of all, we have a choice that we can set an enable line. Okay, first of all, I am setting this as an 1. I am writing here enable first condition, enable equal to 0. So I am setting enable line at 0. So we will see that here input buffer, here I will get 0, so it will be off. Input buffer I am getting at 0, it means deactivated. Okay, see output line here I am getting 0, it is an inverted, so 0, then I am getting 1 here, so this output buffer it's activated. Okay, now we have seen that how we configure GPIO as an output. Okay, then again also see that when enable is 1, I am setting enable line as a 1. We can configure it as in input mode. Okay, again we are going to diagram. I am setting it as 1, then this get inverted and converted to 0 here. So output buffer, so I am getting 0 here, so it is deactivated. And when I am getting 1 here, so I am getting 1 here. Okay, so now you can see input buffer is activated. Buffer equal to 1, so it is activated. So we will proceed further and we see that how these buffers are working or what is inside this buffer. Okay, we go to next methods and so I am taking GPIO as a is in output mode. Okay, I am taking GPIO output mode. So I'm drawing a buffer diagram. Okay, in buffer we have here one P MOSFET and here one N MOSFET here. Okay, P MOSFET drain is connected to VCC. Here drain, source, and here gate. And N MOSFET source is connected to ground, GND ground. Okay, here I have my input, inverted input here. Okay, is input, then giving it to the pin. This is an pin, this is an outside. This is an outside area. We can connect any load. Any load means LED or anything that we can connect. I am connecting an LED here for easy understanding. I am connecting current limiting diode and emitting resistor, then LED connected to ground. So we see the flow of this block diagram. First we take one, okay, to turn on the LED. Turn on the LED. So give one to the input. Okay, as we given 1 to input, after NOT gate we get 0 here. Okay, this 0, we get 0 across P MOSFET and N MOSFET, due to which N MOSFET get deactivated and P MOSFET get activated or turn on, we can say. As this P MOSFET get turns on, so it is connected to VCC. So this LED get pulled up to the VCC through an P MOSFET. Okay, this is the way. So to turn off the LED, we give 0 here. Okay, then after NOT gate we get 1 here. Okay, then this 1 get applied across both of this MOSFET, P MOSFET and MOSFET. Okay, due to which when 1 is applied across P MOSFET, it gets deactivated, and 1 get applied at N MOSFET, it gets activated. Okay, now we can see that N MOSFET get activated, so this LED get pulls down to ground, so LED get turned off. So why we are seeing this? Because this GPIO mode, it is most important thing when we learn microcontroller or communication I2C, SPI, etc.